Good morning. Myself Dr. Gangadhar H. Hugar from Chandigarh College of Engineering and Technology, Diploma in Sector 26, UT Chandigarh. I am before you to discuss electrolysis and applications of electrolysis. Particularly, this lecture has been prepared for the first semester of Diploma Punjab Technical Education. Today we are going to discuss the following points in order to understand the theme of the today's lecture, that is electrolysis and applications of electrolysis. To understand that, we need to know what is oxidation, reduction and redox reactions. Definition of these in terms of old concept of oxidation and reduction and electronic concept of oxidation and reduction. After that, we will focus our attention in classifying these chemical substances based on conductivity, like electrolytes, non-electrolytes and the process of ionization and electrolysis, electrolytic cell and their industrial applications. So, you have studied the oxidation reductions and redox systems in earlier classes as well. Therein, probably must have defined the oxidation and reduction in terms of loss or gain of oxygen or hydrogen. Let us consider these following common oxide formation reactions. The first one, hydrogen reacts with oxygen to form water. It is a common product, and here hydrogen is gaining oxygen. So, it is undergoing oxidation process in which this gains oxygen. On the other hand, hydrogen is gaining oxygen, therefore, it get oxidized and oxygen gains hydrogen. So, it will get reduced. So, if we want to talk with respect to one of the reactant, for example, carbon. So, we say carbon react with oxygen to form carbon dioxide. In other words, carbon oxidizes to carbon dioxide. Similarly, the other oxides you can understand. Nitrogen gains oxygen to form nitrogen dioxide, it get oxidized to nitrogen dioxide. Ozone on the other hand can be get converted into oxygen, get converted into ozone in the atmosphere. That is also a process wherein oxygen undergoing oxidation. Silicon dioxide formation, and this is lot of compounds you can see, glass, sand, etc., in which silicon is combined with the oxygen, that is silicon dioxide. And other example oxidation, iron get oxidized to iron oxide, that is rust, formation of rust is a common example of oxidation. On the other hand, it oxygen oxidizes iron to iron oxide, whereas itself get reduced. So, these are the points which you have learnt in the previous classes. So, but it has got a limitations, because consider the following reaction. Stannous chloride when treated with ferric chloride, it will form stannic chloride and ferrous chloride. Consider the following reaction in which stannous chloride reacting with ferric chloride, and this is a redox reaction. This does not involve any oxygen or hydrogen. So, we cannot explain the oxidation reduction reaction which is taking place between stannous chloride and ferric chloride. Therefore, we are going to define oxidation and reduction in terms of electronic concept after the establishment of atomic structure. So, what is the electronic concept of oxidation and reduction, and we will define redox system in terms of electronic concept. A chemical reaction in which one or more electron transfer may take place between atoms of combining elements. Let us consider lithium solid combines with fluorine gas to form lithium fluoride. Though there are various steps involved in this, I am not going to take up everything, just let us focus your attention on this lithium gas, which is elemental lithium lose one electron and undergo oxidation. On the other hand, fluorine in the form of gas, atomic fluorine gain electron that is being transferred from lithium to fluorine and it becomes fluoride. So, this is atom losing electron, whereas the other atom gaining it, and therefore, this is an example of redox reactions after the loss of electron and by the lithium atom, the same electron being gained by the fluorine and it becomes fluoride. So, these ions are oppositely charged, they combine and they form lithium fluoride, an ionic compound. So, therefore, this also release energy as you have studied in chemical bonding. Therefore, this is a lattice energy. If we sum up all the energies, total energy will be very less that of lithium fluoride when lithium fluoride is formed between the reaction of lithium with fluorine, and hence lithium fluoride is a ionic compound because it is strong electric force of attraction which makes them to hold together. So, this is a ground state electronic configuration of lithium which contain only one electron in its outermost shell, second shell, and here the fluorine is containing 5 electrons, and when this electron is being transferred, see, it will change into lithium cation and fluoride ion, and this will attain octet, this will attain doublet, and thereby which these ions attract each other and hence a strong ionic bond. Here the transfer of electron from lithium atom to the fluorine atom, and the fluorine changes to fluoride, lithium changes to lithium cation, and thereby they attract each other and that makes. So, what we are interested in, lithium metal lose an electron and gain positive charge. So, it is said to be oxidized. On the other hand, fluorine atom gain that electron in its outermost shell to acquire not only the octet arrangement, but higher stability and minimum energy state. Therefore, it is said to be reduced, and therefore, we can define the redox system in terms of electronic concept. When we take common salt, it contains cation and anion held together by ionic bond cation, and it is a common salt. It is strong electrostatic force of attraction between chloride ion and sodium ion cation make it possible to have a stronger ionic compound in ionic compound. So, sodium has lost one electron to the chlorine atom and thereby which they attract each other. So, therefore, in terms of electronic configuration or in terms of electronic concept, oxidation, reduction and redox reactions can be defined in this fashion. According to electronic concept of oxidation and reduction, oxidation is defined as a process in which a species we mean atom, it may be an ion or it may be a molecule which can lose one or more electrons. Let us recollect the previous example, lithium gas loses electron. In this case, lithium undergo oxidation as it donates its electron to fluorine atom. When they fluorine and lithium they combine with each other. Hence, lithium is a reducing agent because itself get oxidized, whereas it reduces the fluorine to fluoride, and as a result it is called as fluorine is an oxidizing agent, whereas lithium is a reducing agent. So, Reduction is defined as a process in which a species, again the meaning of species here, it is as previous, it is either it may be an atom which gain electron, or an ion may gain electron, or a molecule can gain electron. So, we can define the reduction as reduction is defined as a process in which a species gain one or more electrons. In the previous example, so fluorine gas accepting an electron, and it is atomic fluorine which will convert itself into fluoride. In this case, fluorine undergo reduction as it receives an electron from lithium, hence fluorine is an oxidizing agent. Remember, this transfer of electrons can take place easily when the elements they combine with each other. So, therefore, it is ready to lose an electron and hence undergo oxidation, and will lithium get oxidized, whereas in due course of time the fluorine get reduced to fluoride, and thereby which they acquires the opposite charge and they attract each other to form a lithium iodide solid compound. So, a reaction in which oxidation and reduction takes place simultaneously is called a redox reaction. In this case, the both are taking place. So, the element or a species which get oxidized is a reducing agent, and a element or a species which get reduced is an oxidizing agent. So, you should remember this, it is a easy way to remember. Say, let us say oil rig. So, here O stands for oxidation, S is, and L stands for loss of electron. So, oil means oxidation is loss of electron by a species. So, and rig, so R stands for reduction, I stands for is, and G stands for gain of electron. If you remember oil rig, so oxidation is a loss of electron, whereas reduction is a gain of electron. Suppose if you take a species, as in the previous example it was a lithium gas, gaseous atomic lithium, it is a reducing agent. Why? Because itself get oxidized by loss of electron. Here lithium is oxidized, hence it is lithium is a reducing agent, or it is simply called as a reductant. So, in the previous example fluorine gas gains one electron and convert itself into fluoride. Here fluorine is reduced, hence fluorine is an oxidizing agent, or simply we can call it as an oxidant. I hope this is the how we can define the agency. It means what is the reducing agent? Reducing agent reduces others, but itself get oxidized, and oxidizing agent it oxidizes the others, whereas itself get reduced. So, that is how the agency of these species can give their names as a reductant and oxidant. So, some examples, quite number of examples we can give for the redox systems. So, and say ferrous sulphate in presence of air and sulphuric acid, it will converted into ferric sulphate, and therefore, these are all conversion of chlorine to chloride, oxygen to oxide, sulphur to sulphide, nitrogen to nitride, all these are involved gain of electrons. So, they are reduction reactions, and see the potassium, magnesium and ferrous, these species may tend to lose electrons as written in these equations. Therefore, this is loss of electron by these atoms, and hence these atoms are said to undergo oxidation. And remember, the purely oxidation does not take place, whereas purely reduction can also can never take place. So, therefore, this oxidation must be accompanied by the reduction, and hence the reactions are called as redox reactions. For example, you take another iron make to react with sulphur and it forms iron sulphide. So, oxygen get magnesium get oxidized to magnesium oxide. Here we are taking reactant magnesium and we are what is happening to the magnesium, with reference to that we can explain this magnesium oxidized to magnesium oxide. And if I want to say reduction, then oxygen get reduced to magnesium oxide by combining with magnesium, like that. So, oxidation reduction simultaneously takes place. So, you must have seen some of the displacement reactions. Here is one displacement displacement reaction which also involves oxidation reduction processes. For example, a metallic copper is dipped in the silver nitrate solution, and so when copper, this is Ag plus and this is Cu, this is a elemental copper, this is salt of silver, and if you dip copper in the silver nitrate, you can notice that there is a deposition of the silver on the copper rod. So, where silver gets deposited by the action of reduction action of copper on the silver ions, and it will get reduced. So, the itself goes into the solution to form cupric nitrate. So, this solution turns into light blue color because of the cupric ions. So, copper changes to cupric, whereas silver ion changes to silver metal. So, therefore, it is a best example. We can notice the deposition of the silver onto the surface of the copper when the copper is dipped in silver nitrate solution. So, this is a best example, and so many examples we can quote. So, let us come to the classification of chemical substances based on the conductivity. I am not going in detail about the conductivity and all these things. Conductivity is a property of the material which can conduct the electric current. Based on that property, we can classify the chemical substances into two broad categories that based on the properties. Let us try to classify based on the electric property, which is purely a physical property, and a chemical substance can also be classified on the basis of chemical properties also. In this lecture, the classification of the chemical substances on the basis of chemical properties are not of much importance for us, but for your reference I have given here. However, the classification of the chemical substances based on the electric conductivity is quite important, and we want to know what is electrolysis, and as far as electrolysis are concerned, they have something to do with the electric properties of the chemical substances, and thereby which chemical process may also takes place, that is the part of the conductivity of certain substances, and some of them they do not. So, we want to understand this is in clear insofar as chemical substances conductivities are concerned. Therefore, we can focus our attention on the classification of the chemical substances based on their physical one important property like electric conductivity. So, we can just classify the chemical substances into two broad categories based on the whether they conduct or not. So, into the electric conductors and non electrolytes, or non conductor, we can also say non conductors. Okay. So, electric conductors means any material which conducts electric current. Okay. So, it may be an electrolyte, it may be a metallic conductor, it may be a semiconductor too. So, non electrolytes are those substances. We are going to discuss these two important class of compounds which have been classified on the basis of electric conductivity. Okay. So, on the basis of chemical properties, as you know, the chemical compounds can be classified into acids, bases, neutral compounds, etc. Okay. So, we focus our attention only on the classification of element based on the electric conductivities. So, electric conductors, electric conductor, any material that conducts electric current is electric conductor. It may be a metal, non-metal. For example, graphite is a non-metal, though non-metal conducts electric current. So, like that, such as graphite, some chemical substances such as acids, bases and salts, all you see the citric acid that conducts, mineral water from the coconut it also conducts electric current, as the name itself says it is a mineral. So, it contains some electrolytes as well. So, the extent of conductivity may differ, but still it is a conductor. So, we want to know now electrolytic conductors, that is electrolyte. What is an electrolyte? An electrolyte is a chemical substance which can conduct electric current either in its molten or aqueous state. So, one thing you should remember, when you say an electrolyte, it will conduct electric current, but it must be taken either in a molten or in aqueous state. So, electrolyte in its molten or aqueous state spontaneously split into cations and anions. This spontaneous splitting up of an electrolyte is called ionization. So, ions are free to move in solution only after ionization of the electrolyte. If you take electrolyte in solid, they may not dissociate because their positions are fixed in the crystal lattice, hence they are not free to move. But when you take in the molten or aqueous state, automatically ions are get freed from their lattice points and they starts moving. So, therefore, on the basis of the extent of ionization, means to what extent they can undergo ionization, based on that we can have two types of categories. One we call it as a strong electrolytes. Strong electrolytes it is an electrolyte which undergo complete ionization even in moderate concentrated solutions. If I make the solution of that, for example, hydrogen chloride is a gas, put it in water, it will get dissociated into H plus ions and Cl minus ions. H plus can also be written in water as H3O plus aqueous, and chloride ion can be written as Cl minus aqueous, or simply you can write HCl in aqueous medium results in the formation of H plus ions and Cl minus ion. This is hydrogen cation and chloride anion. This splitting is called ionization, and if you apply the law of mass action, which you have discussed in the previous classes, equilibrium, and then we can write this type of equation where the equilibrium constant has a much higher value than unity, and therefore, the extent of dissociation is maximum, and hence they are called as strong electrolytes. The other example we can quote for strong electrolytes are hydrogen chloride in the form of hydrochloric acid, nitric acid, some alkalis, potassium hydroxide aqueous solution, lime water, that is calcium hydroxide, aluminum hydroxide, etc. These are bases or alkalis, and some salts. Many salts are all conduct electric current because they dissociate in aqueous solution. Therefore, sodium chloride, potassium iodide, potassium nitrate, copper sulphate, etc. So, we have the other class of electrolytes called weak electrolytes. An electrolyte which undergo partial ionization even in its dilute solution. I make the dilute solution. For example, you must be having the example in mind. Many times we prepare the food using like acetic acid, acetic acid vinegar, and this vinegar when you put it in water and it is liquid and liquid water, it will get dissociated into acetate ion and hydronium ion or H plus ion in water, and you can simply write this dissociation equilibrium. This is equal to, I am using in reference to the double headed arrow mark pointing in opposite direction, but for simplicity I am using equal here. So, acetic acid in dissolved state will produce acetate ion and hydrogen ions, and they produce this one, and so a non-electrolyte is a one which a non-electrolyte is a substance or a chemical substance which does not conduct electric current either in its molten or aqueous state. For example, you have a sugar crystals, ethanol and oil, they do not conduct. If they ionize, and even the extent of ionization is very weak, and the current what they pass, it is of not detectable one. So, non-electrolyte in its molten or aqueous state does not simultaneously split up into cations and anions. Therefore, there are no ions, there is no conductance. So, that is non-electrolyte does not ionize. So, sugar, glucose, even distilled water, urea, ethanol, etc. are the we can say non-electrolytes. The very important question is why electrolytes undergo ionization in aqueous or molten state. So, let us understand this one. To understand the process of ionization, let us consider the chemical bonding in water, because water is a polar molecule and it is called polar solvent. When there is a large difference between the between the electronegativities of two elements involved in the covalent bond formation, the bonding molecular orbital will not be a symmetrical one, they are asymmetric. As you know, the hydrogen overlaps, the electron density on oxygen increases, and hence there is a net charge of negative on the oxygen, and whereas positive charge partial on the hydrogen atom, and hence therefore, oxygen to hydrogen covalent bond in this is highly polarized, and there is a net dipole moment, and therefore, when you take sodium chloride, dissolve it in water, see this hydrogen orient towards the chloride ions, whereas sodium get oriented towards the oxygen atom of, because oxygen is negative, sodium is positive. Therefore, the attraction force of sodium chloride will be weakened to a point of breaking when you put it in water, and that is the reason why when an electrolyte is added to the water, and because of the orientation of this polar molecule around the cations and anions facing their opposite charge part towards the oppositely charged ions, and due to a strong electrolytic force of attraction which established between these water molecules and ions, makes this the strong attraction force between electrolytes, cation and anion in the crystal to a weaker point of breaking, and therefore, they get separated and they get hydrated simultaneously. So, we can attribute this dissociation of electrolytes probably in water mainly due to its polar nature, and therefore, this is a very important phenomena, and this is how the mechanism occur when an electrolyte is put into water, and many more salts. And you may ask this, why do the other glucose is soluble and water having capability of forming hydrogen bond. So, then we can also explain the solubility of covalent compounds even in water due to the formation, but at present juncture it is polarity of the water molecule which facilitates the dissociation of the electrolyte into its constituent ions from their solid lattice points. So, the mechanism, you got to understand this, the word electrolyte should be explained more. Light is from a Greek word lytos, meaning loosened or soluble. Electrolytes are soluble in water, meaning they are pulled apart or loosened or dissociated by water molecule. See, water molecule dissociates, particularly electrolytes, and water is a polar solvent due to the presence of polar covalent bond between oxygen and hydrogen. Remember, water has a partial negative charge and partial positive charge on hydrogen, hence it is called a polar solvent. Sodium chloride is an electrolyte because it is loosened or broken into cations and anions by water, and therefore, the other examples we can quote many acids, hydrochloric acid, nitric acid, acetic acid, sodium hydroxide, even aqueous ammonia, ammonium hydroxide, calcium hydroxide, these are all other examples of electrolytes. So, conductivity of an electrolytic solution will increase with rise in temperature. Dissociation or ionization will increase with increase in temperature. This will dissociation of an electrolyte in water increases with increase in temperature. Therefore, the even in molten state this will dissolve and they form the free moving ions. Therefore, the molten electrolytes can also conduct electric current. These are the some important facts. The chemical composition of an electrolyte undergo change after the passage of electric current through it. Electrolyte conduct electric current due to ion migration. This is very important. These ions starts migrating in the applied electric field through the electrolytic solution. Cation reaches cathode, whereas where they undergo reduction, anion rich anode where they undergo oxidation. In solid ionic crystal, these ions are fixed to a particular point, and therefore, if you try to pass electric current through a solid electrolyte, even though it contains some ions, for example, sodium chloride is expected to contain even ions at a solid state, but their positions are fixed and therefore, they are not free to move in the solid state, and that is the reason why they got to be separated either by putting them into water, or we can separate them